Okay, so we're gonna continue on to factor. Remember that we are working on factoring mainly because we have rational functions coming up ahead, and that may not make a whole lot of sense why this is relevant, but it will be. Okay, now this factoring was definitely tougher than the one we just did on the last section. So on this, I would probably suggest that you would print the notes. I mean, it has a really nice factoring flowchart here. I guess you can write it if you wanted to by hand. But this factoring flowchart essentially is the way that you need to think about how we do factoring or how we factor something out. Remember, I always say it, look for your greatest common factor. If you have two terms, you're going to look for the difference of squares or sum of difference of cubes. And this chart actually has the formulas for you. On this one, if you have three terms, so if you have three terms, then these are actually the signs you would follow. Normally, I would honestly rather that you logically would come to this conclusion instead of memorizing this, but whatever works for you. And we're either going to do bottoms up or this X factoring that we've done in the past, all right, that we essentially do it like factor by grouping. And then finally, if you have four terms, then you are going to have to try out factor by grouping. After you have done all of this factoring, you need to check and make sure that nothing else can be factored. And that's normally when you're finished. All right, so let's just go ahead and go over number one. Now, number one, notice that I have two terms, so I'm going to be looking to see if it's a difference of squares or a difference of cubes. And again, I'm saying those are my only two choices because I have a minus, right? That minus right there. All right, so I really only have two choices. Now, I'm going to use this formula, okay? Now, I'm going to rewrite that formula up there so I don't have to keep switching back and forth, but this is how the formula works. All right, I'm going to write the formula up here. So you have A plus B, and then you have A squared minus AB plus B squared. I just wrote the one for sum of cubes, not the difference. So I guess I'm going to have to use that one over here anyway. So let me write the difference of cubes formula. So that's A minus B, A squared plus AB plus B squared. Remember, if you happen to remember those letters, then to remember the signs, this is always going to be the same as this one. So if that's minus, right? So it's the same as this one. Same, different sign, always positive. Again, same, different, always positive. Anyway, so to do that, essentially what you're going to do is you're going to think, okay, what is the cube root of x cubed, which is just x? You're going to think, what is the cube root of 8, which is 2? All right, so these are the first two terms that you have. Now, if you can at least come up with those two terms, the next few should be easy because all you're going to do is look at the formula. That's a squared. Now, a squared is this one, all right? So I'm going to square x. So this is x squared. And the middle term, notice that I don't care about the sign. Just follow the same exact signs that you have here. It says AB, which means you're going to multiply x and 2. So this is going to be 2x. And then finally, you're going to square, excuse me, we're going to square that 2 right here, which is going to be 4. All right. And that's basically it. The nice thing about doing the sum or difference of cubes is that this term right here, this trinomial, is not factorable. Okay. Let's go over to number 2. Again, always look for your greatest common factor. In this case, we have at least a common factor of 2. And that honestly turns out to be the greatest common factor. So, and then now you have to think, okay, look at it. You have two terms, you have a plus, your only choice is the sum of cubes. And if you can think of the cube root of 27x cubed, which is 3x, and if you can think of the cube root of 64, which is 4, well, then you're basically halfway there. Okay, so if you can get those two numbers out, honestly, those are the most important, all right? So now, according to the formula, right, I'm going to have a squared, which means I'm going to square 3x. If I square 3x, that's going to be 9x squared. Not 3x squared, it's going to be 9x squared. Minus ab, so we're going to multiply those two, which is 12x. Then finally, we're going to square that last one, which is 16. All right? And that's pretty much it, all right? Just make sure that there's nothing else can be factored out of this particularly. Sometimes you have like a common factor, but if you already got the greatest common factor at the beginning, you shouldn't have a problem. All right, on number 3, same idea, look for the greatest common factor. There's not one. And if you can think of if you can think of now this one's kind of strange for y'all, because you're like, oh, it's a 6, x to the 6, I can't do anything. Well, think about it. Now I have two terms. On this one, if you can think of the square root of 8x to the 6, let me know. There's not a whole number, at least. There's not one, but can you think of the cube root of 8x to the 6? Now the cube root of 8x to the 6, which would be 2x squared. Right, and the cube root of 125 is 5. Alright, okay. So if that is what you got, alright, and remember, if you don't know why, remember the cube root of x cubed, hopefully you know what the cube root of 8 is, but that's the same thing as x to the 6 times 1/3, according to the lessons we went over some time ago. Remember, 6 times 1/3 is x squared. Alright, so I'm just showing you that that's how I got the x squared. Now the cube root of 8 is 2. Alright, now according to the formula, I'm going to square this. If I square this, I'm going to square the 2, square the x squared. If I square an x squared, I get x to the 4th. And I'm going to multiply those two now. So that's going to be plus 10x squared. Now remember that the signs came straight up from the formula, right? So I'm not multiplying 2x and -5. I'm not. I'm just following the signs that were given to me in the formula. And finally, square the 5, which is 25, right? Now next step, look for your greatest common factor. By the way, make sure to look at these to see if you can, at least this one, not so much this one. This is not going to be factorable, but this one could be. In this case, is not. This is not a difference of squares. All right, number 4. We're going to factor out of 5. I know that at least I have that. I have 3x cubed plus 1. Now, some people might be tempted to think that this right here is the sum of cubes, but it's not. The cube root of 1 is 1. Okay, that works. But the cube root of 3, there's really not a cube root of 3. Not a 1. It's not a perfect cubed. So therefore, that's all I can do. I'm done. All right, let's go over to number 5. Right, on number 5, we have two terms. All right, we have two terms, and then now see if it's a difference of squares or a difference of cubes. In this case, let's try difference of squares. The square root of x to the 4th would be x squared. The square root of 81 is 9. Oh, that works. So this is, and the reason I say the square root is not so much that you're taking a square root, you just have to realize that this number is a perfect square, and so is this one. Okay? So now, check those two out. Can any of these be factored one more time? This one cannot be, because this is not a difference of squares. Remember, if it was a difference, we have a minus. But this one can be factored one more time. This would be x plus 3, x minus 3, because this one, remember this part right here, is a difference of squares. Alright, moving on to number 6. Let's take out the common factor first. In this case, that's a 3. I have x to the 4th minus y to the 4th. Alright, now this one is normally a little trickier for you because they're sliders, but it's the same thing. See if it's a difference of cubes or a difference of squares. In this case, this is a difference of squares, and the reason I know that is because I can take the square root of x to the 4th, which is x squared, and the square root of y to the 4th would be y squared. So again, you just have to realize that those are letters that you can't take, that are perfect squares, essentially. Okay. So now, look at each term and see if you can factor this one more time. And just like this one, right, this one right here is a difference of squares again. This one's not, because that one has a plus. So therefore, it cannot be a difference of squares. All right. So this is x plus y, x minus y. And that's pretty much it for that one. All right, let's go into number 7. And number 7, so on this one, it looks like we have no trinomial. So I guess we're kind of hoping that you know how to do this already. All right, we're going to factor out as 16x squared. And then we end up with x squared minus 2. Now notice that on this one right here, you have to see if this is factorable. And it's not, because even though it's a difference, this 2 is not a perfect square. How do I know that? Do you know the square root of 2? Well, if you don't know, at the very least you should know that it's not a whole number. It's not a rational number. It's actually an irrational. So that's it for that one. Right, on number 8, same thing. This turns out to be a difference of squares. Now, unlike number 5 and 6 here, x squared plus 7 cannot be factored. We already know that. It's not a difference of squares. this one, just like that one, it is a difference, but a 7 is not a perfect square, so therefore, I cannot factor it any further than this.